Hello, sir. My name is Saktivel. Today I'm going to be talking about the second lab for this semester, which is under the topic of fluid dynamics. And we're going to be experimenting about Bernoulli's theorem. So, as an introduction, the flow of fluid must conform with several scientific principles, in particular, the conservation of mass and the conservation of energy. The first of these is when applied to a liquid flowing through a conduit requires for steady flow of velocity will be inversely proportional to the flow area. The second requirement that is if the velocity increases, the pressure must decrease. Both Bernoulli's equation and the continuity equation are essential analytic tools required for the analysis of most problems in the subject of mechanics of fluids. And that is the formula used for this experiment. In terms of the objective, is to validate the um, is to investigate the validity of the Bernoulli's equation when it's applied to a steady flow of water through a tapered duct. And to do this experiment, the methodology that we use is we use the Bernoulli's apparatus, also known as a Venturi system, as you can see in the diagrams pasted on the left. In this experiment, the validity of Bernoulli's equation will be verified with the use of tapered duct Venturi system connected to a manometers to measure the pressure heads and the total head at known points along the flow. The flow area at each taping is tabulated as seen in the second figure. The second figure, that's the taping number and the flow area. In terms of the procedure, place the venture meter to a horizontal surface and note the height of input valve and output valve and make sure they are the same. Then attach the apparatus with the power supply to keep the supply off and open all the air bleed valves of the manometer present at the top. Secondly, turn on the power supply to run the pump and adjust the flow rate control valve until water is level in all manometers at a readable range. Then place stop plug in the basin and note that the time required to fill the basin with specific amount of water. Remove the stop plug to drain out the water from the Venturi system. Place the dynamic pressure probe with the static pressure pot and measure the manometer data from both probes. Now place the dynamic pressure probe with the next static pressure probe and measure the manometer data from the probes. Repeat the above steps for all the measured data from the manometer probes. So as you can see, from the result table, the test was ran 3 different times, which yielded 3 different flow rates and of course different values as well. The static head probe gives us the static head value. The dynamic head probe gives us the dynamic head value. And there are 6 different heights and 6 different values for each test because 6 different manometers were used, yielding us in these 3 graphs for test 1, test 2, and test 3. So in conclusion, from the experiment conducted, it was successfully demonstrated an experiment on Bernoulli's theorem. Based on the experiment, different cross-sectional areas will give different pressure and different velocity, thus changing the flow rate on each of these segments. The velocity of fluid increases as the cross-sectional area decreases. This experiment is most suitable to be used to verify Bernoulli's theorem as a theoretical value, and the experiment value can be calculated is not much different, which means this experiment is a success and is done with high accuracy. With that, I'd like to end my explanation. Thank you for your time. Have a wonderful day.